This is Mr. Gertz back with another flipped chemistry lecture. This is going to be the first lesson for Unit 2, which is going to be about matter and some properties of matter. So let's start talking about properties of matter a little bit. First of all, there is a difference between extensive properties and intensive properties. And you can follow along with these in chapter 1 of the book if you would like to. So first of all, what is a property? Well, a property is going to be a characteristic that defines a thing. Length, width, height, color, maybe what the thing does, maybe what the thing smells like, what the thing tastes like, although we won't be doing a whole lot of smelling and tasting in chemistry. Now, an extensive property, this is a property that is going to depend on the amount of something. So try to think for just a second about what sort of property this could be. So an extensive property then would depend on the amount, so length or the mass of an object would be an extensive property. An intensive property, and you can think about this as being something internal, something what makes the thing what it is, does not depend on the amount. Any of these intensive properties, doesn't matter how much that it has, that property will be the same. For example, color. If you have a yellow highlighter and you cut it in half, it's still going to be the color yellow. Or you could think, for example, density. If you have a cup of water and then you pour half of it out, it's still going to have the same density as water. We'll get to density in another lesson. We can also divide properties by whether they are physical properties or chemical properties. A physical property is one that can be measured without changing the identity of the substance. A physical property is going to be something like length, color, mass, what something is made out of, maybe even what something looks like. These are physical properties. A physical change is going to change those properties but not change what the substance is. So a physical change, for example, take a sheet of paper, you cut it in half. It's still a sheet of paper. Is boiling water a physical change? Think about that for a minute. So when we boil water, what happens? It changes from a liquid to a gas. You might be tempted to say that's not a physical change. However, if you think about it, it is still water. The particles didn't change what they are. They were water molecules before, they're water molecules afterwards. They changed state, and that's going to be a physical property, states of matter. You've probably studied states of matter ever since elementary school, so we won't dwell too long on this, but do remember that a solid, the thing that you see on the left there, the left of the right, has a definite volume, definite shape. Look at your textbook, for example. Not a great example because it is a little squishy because there's some air in there. So what else do I have lying around here? A Expo marker, dry erase marker for drawing on the board. Its shape is not going to change unless it undergoes a phase change. And also its volume, its size does not change. That's a solid. A liquid, if you pour water into a glass, it doesn't have a definite shape because it takes the shape of the glass. If you pour it out on the table, the shape is going to change. However, the volume stays constant for a liquid. In a gas, you have an indefinite volume and an indefinite shape. A gas will take the shape of its container, and it will also take the size of its container. If you put a hole in a balloon, that gas goes out and it's going to fill the entire world. Given enough time, a particle of gas will go all over the world, which is sort of interesting if you think about it. You might be breathing in some of the same air that Jesus breathed in. In fact, the odds are fairly good, and we will talk about that later this year. There are two more states of matter that we don't have to worry about in chemistry class because we won't come across them. Plasma being one. If you take a gas and you excite the atoms either with electricity or heat, you can get them to become ions, which means they lose their electrons. More about ions later this semester. But that's a plasma, different from blood plasma, which is a liquid inside of your body. Plasmas you would find more often in fluorescent lights or in the sun. Also, Bose-Einstein condensates. Now, these are going to be very rare. You don't find these in nature. You only find them in laboratories where the temperature drops very, very close to absolute zero, and all sorts of weird stuff happens. You can look those up more if you want, but I will not dwell on them here. So again, these are physical properties, solid, liquid, gas. A change from one of these to another does not change what the thing is. It's still going to be metal. So if you take iron and you melt iron, it's still iron. It did not change what it is. It's a physical change. Now this is going to be different from chemical properties. Chemical properties tell us something about the ability of that object to undergo a change that transforms it into something else. Flammability is a chemical property. The ability of something to rust is a chemical property, because when iron rusts, it actually is no longer iron. It's become a new substance, iron oxide. So a chemical change then is when the substances actually change into other substances through a chemical reaction. And that's really what we're more interested about in chemistry. That's what we're going to be focusing a lot on this year. How does something change from one thing into something else? It's really the core of chemistry. How will you know that a chemical change occurred? Well, there's a lot of signs. Here's a couple of the more common ones. Light is produced. Heat is transferred, so either the substance becomes warmer or colder. You saw in the lab the other day, baking soda and vinegar, the temperature actually dropped. Production of a gas, which you also saw in the baking soda and vinegar lab. It made a lot of bubbles. A color change. Some color changes. If you take a piece of wood and you paint it, sure, it changes color, but that is not a chemical change. It's still a piece of wood. It just has paint on it now. Formation of a solid. We'll see later this year, sometimes you can mix together two colorless liquids and it will change into a yellow solid and fall to the bottom of the beaker. That's called a precipitate. That can be a sign of a chemical change as well. One more thing that we need to talk about properties is mixtures. We're going to talk more about mixtures in another presentation, in one where I talk about density, but there's a little bit I do need to address right now. There's a difference when we talk about properties of whether something's a pure substance or a mixture. A pure substance means it's something that cannot be separated without a chemical change. For example, water. If you've got pure water, it can't be separated. If you pour it through a filter, it's still water. Now, if you had dirty water, water with sand mixed in it, that's not a pure substance, because you could put a very, very fine filter in that. When you pour it through, the dirt's going to stay behind on the filter. Pure substances can either be elements. Elements, as you'll recall from earlier classes, you can find on the periodic table, or compounds. Compounds are substances made from a mixture of elements. Much more on compounds later this semester. A mixture, on the other hand, can be separated without chemical change. You can separate two things from each other. That's why I have this picture of this teddy bear here. That's a mixture. More than one compound. There's fluff inside that's different from the outer covering of the bear. Again, there's different types of mixtures that we'll talk about in another video. Homogeneous, heterogeneous, solutions, colloids, all those still in this chapter, but in a later video. Those, if you want to learn about them right now, you can turn to chapter 1 in your book also for those. That's going to do it for today. Thanks for watching.